I'm Rafael Gonçalves. I'm a research scientist at the Stanford Center for Biomedical Informatics Research at Stanford University. And in this talk, I will describe software developed by the Protégé team and how various collaborations between our team and industry have led to substantial improvements and to new functionality in the Protégé software. I'll describe what these new features are, how people have worked with them, and where our team is going from here. The Protégé team at Stanford has been developing and maintaining knowledge representation software since the very early 90s. It all started with the Protégé desktop tool, which is a platform-independent, open-source software for building ontologies. Protégé has an extensible architecture that allows third-party developers to create plugins which enhance the core functionality of the Protégé software. About 12 years ago, the Protégé team realized that there was a need for a tool that facilitated real-time collaboration between ontology developers and subject matter experts. So the Protégé team developed WebProtégé, a web-based ontology editor that is rich with features for collaboration, and it has a simplified user interface for ontology editing. So nowadays, our team supports two different yet complementary tools, the desktop Protégé and WebProtégé. And in this talk, I will focus on WebProtégé. I'll just say a few words about the Protégé user community. Over 365,000 users have registered to download Protégé software, although we don't require them to do so. Over 21,000 users subscribe to Protégé mailing lists to receive announcements, user or developer support. Our users actually support each other through these mailing lists, sometimes even before we get to read the help requests. Protégé tools are used in all sorts of settings, in academia, in industry, and in government. With a community as diverse and large as the Protégé user base, and with Protégé being an open source tool and it is easily extendable, this has meant that there have been numerous code and plugin contributions from Protégé users and from third-party developers throughout the years. WebProtégé, shown here in this figure, is a modern web-based ontology editing environment. Essentially, it is a Google Docs for ontologies. In short, ontologies are machine processable artifacts that represent the important concepts and the relationships that hold between these concepts in some domain of discourse. WebProtégé is an open source project. It is licensed under the BSD2 clause license, and it is free for everyone to use. The figure here shows the main WebProtégé user interface displaying the so-called Arrow project. This project bears no relation to any of the ontologies or knowledge graphs that I'll mention later. It is used here merely for illustration purposes. The left-hand side of this figure displays the class hierarchy containing various tagged classes. The center display displays the content for the selected class. In this case, we have selected L1011, and this frame shows us everything that the ontology has about this entity. The right-hand side displays threaded discussions for the selected class, and it shows recent editing as well as commenting activity that has occurred throughout the project. We provide a hosted solution for the community at webprotege.stanford.edu, where anyone can create ontology projects. People just need to sign up and create an account. As of this week, we have over 70,000 registered WebProtégé users, and we have just over 100,000 projects on this hosted version of WebProtégé. Besides the hosted version, we produce releases that third parties can download and run privately. This is typically how industry users such as Cisco and Pinterest have deployed WebProtégé. WebProtégé was designed to allow users to collaboratively edit ontologies, much like Google Docs. It features various aids for collaboration, and I will just give you a flavor for these here. We have change tracking. Changes are tracked by user, entity, and timestamp, and they are replayable so that they can be used for producing intermediate versions of projects, or for computing diffs, or for rolling back changes. The tool also provides high-level descriptions of the changes that occurred, which are designed to make it easier for users to browse and to understand the changes that have happened. WebProtégé provides a simple but very effective issue tracking system. Users can post discussion threads per object, and these discussion threads can be managed and they can be resolved in a way similar to traditional issue trackers. We also have hooks in the system for change notifications. Users can be notified of changes to the ontology, changes to parts of the ontology, posted discussions, etc. over Slack and via email. So that is a very quick overview of WebProtégé. Now we'll go into a few more details later. The language that WebProtégé works with is called OWL, that is the Web Ontology Language. It is the latest standard in ontology languages, and it is the most used ontology language worldwide. An OWL ontology is simply a set of statements, and we call these statements axioms. I'm not going to say much more else about OWL, except that the language itself is highly expressive, and it provides a rich set of primitives and constructors for building expressive ontologies. And it's a World Wide Web Consortium standard, with the World Wide Web Consortium being the key standards body for web technologies from HTML and CSS through to knowledge representation languages like RDF and OWL. One of the goals of WebProtégé is to tame the complexity of OWL and the intimidation factor that this complexity brings with it. To this end, WebProtégé provides quite a simple user interface out of the box. Class descriptions and individual descriptions are simply displayed as frames of information. In this slide, you see the simple frame-based display of information in WebProtégé on the left-hand side, and the underlying OWL code on the right-hand side. I don't expect you to read these OWL axioms. I just want you to notice that OWL is an expressive ontology language, and that there is a fair amount of complexity under the hood that we do our best to shield our users from. Historically, the majority of the funding for the Protégé project has come from the National Institutes of Health. We have also received funding from the National Cancer Institute in the US, as Protégé is their editing platform for the National Cancer Institute Thesaurus, or NCI Thesaurus for short. For a long time, our primary focus has therefore been on supporting the biomedical ontology engineering community. We've actually led the way in terms of producing application-oriented ontologies such as the gene ontology or the ontology about chemical entities of biological interest, or CHEBI for short, among many other ontologies. However, more recently we have been seeing more and more interest in the use of Protégé for ontology editing in commercial settings. Commercial ontologies or knowledge bases, which are also known as knowledge graphs, tend to be much larger than what we, the Protégé team, have traditionally been used to working with. In recent talks at the Knowledge Graph Conference and the International Semantic Web Conference, I described the collaboration between our group and Pinterest on building an ontology that forms the core of the Pinterest knowledge graph. I won't go into detail here about the engineering of the Pinterest graph, but instead I'll briefly describe the WebProtégé features that we developed to improve its construction, maintenance, and curation. After that, I'll describe the kinds of functionality that we've been building in WebProtégé to facilitate the engineering of the Elsevier medical knowledge graph and of the BASF chemical knowledge graph. A feature that has been heavily used in the development of the Pinterest ontology is called entity tags. These tags can be used to highlight entities in a colorful way in the WebProtégé user interface. Each tag is assigned a label, an optional description, and a color, as you can see here in this screenshot. These tags can then either be manually assigned to entities, or they can be automatically assigned in a live query-based way. Tags can be automatically assigned to entities in an ontology based on structural criteria, as I'm depicting here in this figure. This tagging feature supports complex, multiple conjunctive and disjunctive criteria, along with paths of values to be matched. Here, the automated tagging criteria specify that any subclasses of Airbus aircraft that are missing a value for SCOS definition will be tagged with a tag called missing definition. It is then possible to search for entities that have been tagged with a specific tag or with multiple tags. This can be done using the traditional search feature in the WebProtégé tool by typing the tag name in the search text field. The entity tags feature was adopted by other users fairly quickly, and this screenshot is an example of that. I'm showing here a public ontology developed by Highways England, which is currently maintained in WebProtégé. As you can see, the ontology developers have made extensive use of entity tags throughout the ontology. Note also that the tags are not only displayed in the class hierarchy in the left-hand side of the user interface, but they're also displayed at the top of the entity description view, which is shown here on the right-hand side of the figure. Another key feature that was essential for Pinterest curators was having support for multiple languages in the user interface. In particular, it was essential to display entity names in a secondary language across the class hierarchy, as depicted in this screenshot. Here, the primary display language is English, and the secondary display language is Hungarian. The secondary display name is shown to the right of the primary display name. The colorful tag that you see in the UI with HU highlights the classes that are missing a Hungarian label. So, one way or another, entities that are missing labels can be easily identified in WebProtégé. Finally, during our collaboration with Pinterest, we built a querying mechanism and the user interface which caters to the most common kinds of queries that users perform in ontologies. In this screenshot, we are searching for subclasses of Airbus aircraft that contain the string passenger in their labels, and the results are shown at the bottom of this figure. The expressivity of the queries that can be done here comes close to a shackle core implementation disguised in a user-friendly form. About a year ago, we released this graph visualization interface shown in this figure here. The graph displays all of the relationships that a selected entity, in this case the Airbus aircraft A350, is the subject of. Subclass of relationships are shown in solid yellow, while custom relationships are shown in blue, such as the primary manufacturer of Airbus aircraft. When exploring tools to edit and to curate the Elsevier medical knowledge graph, WebProtégé came up as a natural candidate. This feature in particular was of interest to the Elsevier team, as it provides a useful bird's-eye view of the relationships that hold for a particular entity without overwhelming the user too much with information from other entities. Because of the enormous amount of relationships that a given entity can be involved in, the graph visualization can become difficult to browse and to navigate, in particular for extremely large ontologies or knowledge graphs. So, in collaboration with Elsevier, we have developed a mechanism to specify and to apply filters to the graph visualization. Each filter has a name, a status, that is whether it is active or not from the get-go, an optional description, and definitions of what edges should or should not be included in the visualization. We can add multiple criteria for inclusion or exclusion of content in the graph. For example, here we have two filters in this figure. The first filter specifies inclusion of subclass of edges and exclusion of edges where the head node is deprecated or where the tail node does not have a label on it. These were just examples. The second filter specifies inclusion of edges where the edge property is engine configuration. Applying these filters just described to the visualization shown in the earlier slides, we get the graph in this figure. Notice that the applied filters are listed at the bottom of the user interface, and we can add or remove these filters quite easily. Finally, it is possible to export the content of the graph visualization from WebProtégé in the form of an SVG vector image file. Now, all of the functionality that I've mentioned up until now is included in the live version of WebProtégé. So if you log on to it now, you'll see all of this. Now, the work that I'll describe next are features that are under development currently. And so you won't see them straight away, but they will appear in the future. Beyond the standard editing interface in WebProtégé, We have been building functionality that makes it possible to create forms for viewing and for editing entities in an ontology. We've been doing this work in collaboration with Elsevier, who use these forms for subject matter experts to view and to curate content in the graph. We can add customizable form-based presentations and simple visualizations that provide controlled knowledge entry. They also provide an efficient and pleasing way to browse ontologies for both experts and unexperienced users alike. Forms are displayed upon the selection of entities that match specific criteria, similar to the way that entity tags can be assigned to entities. The form here displays an easy-to-view and to-edit presentation of the logical description of selected classes. In this case, the amino acid alanine from an ontology about amino acids. In this and the next slide, I'm briefly going to demonstrate the creation of the amino acid form that I just showed you before. So in this form, we start by defining a field that represents the name of the object with a default language English. It's possible to add some optional help text to each field. We then specify how the value for this field binds into the ontology. In this case, we define that the value will become a relationship value of the selected subject. Remember that a specific form gets activated when we select an entity that triggers that form, and that this entity is the subject of the relationships defined in the form, unless we otherwise state it. Other options here would be to bind acquired information to the parents, to instances, or to subclasses of the selected entity. We can specify common form settings, such as optionality, that is whether the field is required or optional, and repeatability, that is whether the field appears only once or multiple times in the form. Then we can choose what happens if the selected entity gets deprecated, how the form fields will get displayed in the form interface, and finally, what kind of form field this is. In our case, this is just a simple text field. In this portion of the form, we are creating the charge form field. Remember that this field only has 3 possible values: negative, neutral, or positive. First, the input value for this field is specified to bind to the hasCharge property. This means that the input value will become the filler, or in other words, the object of a hasCharge relationship. The other major difference between this field and the previous one is that this is specified as a single choice type field, which gets displayed in the interface as a segmented radio button. The possible options for the form field can be specified to be a fixed set of values, or they can be drawn from the existing values in the ontology in a dynamic way. In this case, we are specifying that the possible options for the charge field are the subclasses of the charge class in this ontology. So the options are dynamically populated from ontology content. After we specify the other fields to acquire the information that is intended to define an amino acid, we end up with a complete amino acid form, which I'm showing you here again in the middle view of the WebProtégé user interface. And so this wraps up the core of the work that we have been doing in collaboration with Elsevier. The next and last collaboration I'll mention is with BASF, the largest chemical producer in the world. The National Cancer Institute Disorders is an ontology that we would traditionally call large. It contains over 2.5 million axioms that describe over 157,000 classes. Now, when we come to the BASF chemistry ontology, it is in a league of its own. Out of all the enterprise ontologies that we have seen, the BASF chemistry ontology is by far the largest. From our point of view, it is tremendously large. It contains over 700 million axioms. That's 700 million axioms that describe over 30 million classes. So what this means is that the BASF ontology is 3 orders of magnitude larger in terms of axioms than what WebProtégé was originally designed for. So the challenge is on. The good news is that BASF have successfully used Neo4j for holding the chemistry ontology. So we proceeded down the route of re-engineering WebProtégé so that it can interface with Neo4j. Now, to achieve this, we set out to design a mapping between the Web Ontology Language, OWL, and labeled property graphs supported by Neo4j. We also produced a software library that allows us and other people to extract, transform, and to load ontologies into Neo4j graphs. And this library also allows us to view and to manipulate Neo4j graphs through the lens of ontologies. Now, although we have used Neo4j as a backend technology in this project, the architecture that we built into WebProtégé is very flexible. So in principle, WebProtégé can be made to work with any backend graph database. We have designed and implemented the very first comprehensive mapping between ontologies and Neo4j graphs. This allows us to store arbitrary ontologies in Neo4j. Our approach to representing ontologies in Neo4j knowledge graphs means that we can capture anything that can be expressed in the OWL2 language. It's a clean and uniform representation that is easy to query, and it's also bidirectional mapping so that we can round-trip ontologies to and from Neo4j graphs without any loss of information. I'd like to note that while there have been previous efforts at representing ontologies in Neo4j graphs, or labeled property graphs in general, these efforts have been somewhat narrowly focused, and they are either severely limited in what can be expressed. In other words, they are not complete for the OWL language, or they're single directional mappings, meaning that ontologies cannot be round-tripped from the labeled property graph format, or these representations are at the wrong level of abstraction, meaning that they would be extremely verbose and hard to manage. We then re-engineered WebProtégé so that it can interface with Neo4j, and this gives us the ability to display and to edit extremely large knowledge graphs in WebProtégé. I'll say again that the chemistry ontology developed by BSF is 3 orders of magnitude larger than anything that we have dealt with before. Our initial investigations indicate that Neo4j can handle the chemical ontology with our chosen representation, and we note that WebProtégé, with Neo4j backing it, is responsive enough for browsing and for editing an ontology of this size. Finally, although we have focused on Neo4j graphs, the representation that we came up with is not specific to Neo4j. It would work in any store that is capable of supporting labeled property graphs. The main point here is that we can now map OWL ontologies into labeled property graphs, and WebProtégé can be made to work with a backend graph database. To wrap up, I'll now give you a glimpse of what we've got planned for next year. First off, we plan to release the customizable forms feature that I discussed. Next, we hope to support identity management using Keycloak so that we can allow common single sign-on options such as Google accounts. We then plan to implement support in the WebProtégé user interface, as well as APIs, to support curation, reviewing, and issue tracking workflows. A last feature that gets requested a lot is finer-grained user access control. So we plan to provide support for customizing user roles and to tie those into specific ontology operations. Finally, as we gain more experience with editing enormous ontologies in WebProtégé, we expect to implement major enhancements to the user interface to accommodate the visualization and management of content of such magnitude. And with that, I would like to thank the organizers for having me, and I'll take any questions. Thank you.
What can you do in Protégé desktop that is not possible in WebProtégé and vice versa?
That's a great question. So Protégé desktop was designed as an expert system where you can do pretty much anything that you might think of with ontologies, and that includes in particular reasoning. Protégé desktop has by default reasoning support, and it has this plugin architecture that has allowed other developers to build and to contribute reasoners that can be used within Protégé desktop. We also have different querying mechanisms in the desktop version, And we've also got justification systems that allow you to ask why is it that a particular axiom holds or is true. And these features are not in the web version of Protégé. So WebProtégé does not currently have reasoning support, and the querying capability is that which I've shown you here in this presentation. Now, WebProtégé does have a lot of other things that the desktop version doesn't have. And this is very much what you've seen in this presentation. So the tagging system is not in the desktop version. The forms are not in the latest version of Protégé desktop. It used to be that there was a version of Protégé that had the form system, but in the latest iteration of the desktop version, that's no longer true. So forms will be exclusively in the web version of WebProtégé. And we've also got this entity-based visualization in WebProtégé, where you select an entity and you see all the relationships focused on that entity outwards. In Protégé, we do have visualization plugins that have been contributed by the community, but these tend to be visualizations of the entire ontology. So you get a lot of information there, and oftentimes this is just too much to handle. In WebProtégé, we've discovered that even an entity-based visualization is already too much in many cases, and we've had to develop this filters mechanism to cater to that. And so to have a visualization of the whole ontology in desktop Protégé is helpful, but only in certain scenarios. And WebProtégé takes that a few steps further by providing all of the flexibility that I've described here.
So it sounds a little like Protégé was the experimentation platform, and WebProtégé is taking the best of that, the best practices, and implementing them in a coherent tool. That's at least what I'm feeling now. Use of SCOs. Does WebProtégé support the use of SCOs? Taxonomies.
So in general, Protégé and WebProtégé are OWL tools, and so we play by the semantics of OWL. So while we can use SCOs as non-logical parts of the ontologies, so as to have annotations, SCOs annotations, for example, for labels, preferred labels, definitions, and whatnot, the tools themselves are only work with OWL semantics, so they will not. So SCOs narrower or broader are not catered to in Protégé tools, but you can use terms from the SCOs vocabulary in OWL ontologies, and so that's the compatibility that is provided.
Great, thank you for your answer. So a lot of excitement around the forms in the questions, and the first question from Olivier is, forms are for classes, right? Not for instances.
Forms can be for classes and for instances. In this new form system that we've built in WebProtégé, we've designed it so that it can acquire information not just about classes but individuals as well, and it can actually acquire information that describe not just one entity but multiple entities. So if you wanted to acquire information about the subclasses of Airbus aircraft, as you saw in the screenshot in the figure, we can actually do that. So we can describe classes, individuals, or collections of these in some cases.
Great. And what's the release date for the forms, and is there a beta version we can play with?
This is a good point. As you know, all of the software that we do is open source. So if you actually go on to the WebProtégé GitHub repository, you'll find this forms feature is in a branch of the WebProtégé code base. So you can absolutely experiment with it, install your own version of WebProtégé with the forms branch and play around with it. It is not yet live, and we don't expect it to be this year, but we do expect to release it in the first quarter of 2021. we don't have a fixed date, but in the next few months we would hope to have it. But in the meantime, you can experiment with it, and it's quite easy to install your own version of WebProtégé in your own system, and we're always here to help in case.
Thank you. A couple questions about the BASF ontology, the chemistry ontology. Frederick asked if the ontology is open and available.
No. So all of these, both the Pinterest and the Elsevier and the BASF knowledge graphs that we've been working with, they're all proprietary. So they're not open to the public. We basically can describe the kinds of work that we did to allow these companies to engineer and curate their knowledge graphs, but we can't describe their content, unfortunately.
So I've heard in your vocabulary the use of the switch from ontology to knowledge graph on a fluid continuum, and especially for this BASF. So you call it a knowledge graph. So my question was, so these 700 million axioms actually are ontology instances, right? There are entities of a knowledge graph. Is that correct?
That is correct, yes. So all of these 30 million classes or so that are described by these 700 million axioms, they're all at the class level. They include public ontologies such as the gene ontology or this chemical entities for biological interest ontology, because these can be reused to define chemicals that are of interest to BASF. And so the representation itself is very much at the OWL level, not a lot of instance data, but to go back to the flow between ontologies and knowledge graphs, I have done it I've said this in a way that ontologies are typically used as the basis for the construction of these knowledge graphs, or at least it has been in the cases that we've been dealing with. So Pinterest, for example, has built an ontology, and then they have other databases from which they extract relationships that connect these databases to the ontology. So everything becomes one giant knowledge graph that includes a logic-based representation of the things of most interest and the logical definitions that can be done, and those that are of interest for reasoning, those are expressed in OWL. And then you've got these other bits of information coming in from other databases, which are basically like triples. And these will bridge the gap between sort of relational databases or other kinds of databases and ontology level knowledge. And this is sort of the same in BASF and Elsevier, where they want to have a high-level description of the entities in their domain, and have that be the basis upon which they interlink all of the data in their databases that can be and that they are interested in mapping to ontologies and querying using ontologies.
Great, thank you. We're almost out of time. Maybe one small question from Daniel. Is there any plan to add a graphical editing functionality? So I'm not exactly sure how to interpret that. Maybe directly on the graph. Visualization would be the question.
So basically, sort of like drag and dropping things in the graph. Right now,
size like grapho. So yes, that would be dragging and dropping nodes and relationships.
Right. So at the moment, we don't have any plan to do this sort of to have this kind of support. Basically, because we've not really had a lot of interest in it, and so there has been interest in doing things like bulk operations in an ontology. And this was something actually recent that I didn't mention, but that we did in the Pinterest work, because it was useful to be able to take a chunk of the ontology and just sort of like a subclasses, an entire tree, and just put that onto another part of the hierarchy. And that is possible. But we've not had much requests for the other way around, doing this sort of fine-grained drag and drop things in the graph, although we can totally see that it might be desirable in many cases. We've not had much push for it, but we'd be happy to consider it.